Okay, welcome back, everybody. We have Craig O'Neill with Teledyne FLIR. He's an experienced global business development manager with an extended tenure working in multiple industries with a focus of the oil and gas industry, skilled in business development, strategic planning, industry analysis, marketing strategy, and back-to-back consultative sales. I think it's from your LinkedIn.
Probably. Thank you. Appreciate it. So yeah, I appreciate the time here. Thanks for, like I don't know if anybody was here for the previous one. There's a lot of presentations. So you taking your time to come here and sit in on this one. We appreciate it. And hopefully you grasp something out of here. I'm just curious, how many of you sat in on the QOGI training? I think it was yesterday morning. So just so you know, there may be a little bit of duplication, but we're going to talk about some of the newer technologies towards the second half of that in what we do. I think I'm going to do real quick and this so I can actually see the presentation. So what, the first thing is what is quantitative optical gas imaging. And what we're able to do here is we're just using the technology that we've had through FLIR and optical gas imaging for the last 16 years when we came out with the commercial optical gas imaging camera in 2005. For the first, realistically, for the first 10 to first 12 to 14 years, the biggest question that we got, anybody that worked at FLIR in the optical gas imaging spectral said, does it quantify? That was the number one question. And so our entire argument was about quantification and how quantification doesn't matter and all of this. Well, now we have to change our entire scope because now we do have that solution and we do have that technology to be able to quantify. So the great thing about the QOGI technology is that we're utilizing a technology that has grown a lot, that a lot of people have learned. It is, in the upstream world, at least if you will, in the newer regulations, whether you want to talk about upstream EPA or whether you want to talk about some of the more progressive and newer regulations, even in downstream, like in Canada, the QOGI solution is, or the OGI technology in some of those regulations, the QOGI solution is an approved and preferred method for use for emissions mitigation. Oh, and yes, this is the algorithm that's used, and we'll actually quiz you on what all those mean here in a little bit. So just go ahead and see. Why would you want to use QOGI? We talked a little bit, those of you that were in this previous one, about alternative work practice and using optical gas imaging in doing this. Well, if there is a requirement for quantification, if there is a requirement to use to actually quantify the solution in alternative work practice, to 21. There is not a requirement. If you're using the optical gas imaging technology, there is not a requirement. The reality is, at the minimum level that you can see, if you can see a gas with an optical gas imaging camera, you need to fix it. Pretty plain and simple. Doesn't matter what the quantity is. Would quantification be easier for emissions inventory metrics, potentially better reporting purposes than bottom-up type of stuff? Yes, but with OGI in that world, it does that. But if you did need to quantify, if you were wanting to get better metrics and better things, it's, with OGI, we're able to see, that picture's worth 1,000 words. Well, videos must be worth 1,000,000 because we're able to actually see what's happening. We're able to see where, if you're using, technology that may be existing today, that may have been developed in the 80s. I like to say you're looking at a needle in a haystack. But the difference is with an OGI camera, you're doing it with a metal detector. We can actually see what's happening. We can actually figure out, see what you see, where the leak is coming from, know exactly where to actually quantify, where to point the camera, where to put the ring when we do the quantification, where to put the solution in the tool. So it's a huge opportunity to understanding what's actually happening. The other one is the difficult to measure. The difficult to measure components or realistically unsafe to measure, the DTMs or the UTM components. With optical gas imaging, you can broaden your detection capabilities, and now you can quantify that with the QOGI technology in a DTM or a UTM type of component. This is just built up. Even if you had this, it'd be very unsafe to measure this to get in and out of all of those all the piping. Not to mention, if you want to be honest and look at actual emissions that would happen in a leak of this size, to be able to build scaffolding around here for 4 days in and out. You got somebody driving in for 4 days to build scaffolding. You do your LDAR, you drive out for 4 days. Imagine the emissions as far as CO2 equivalent that would happen just in the vehicles of two people driving in for 4 days from an average of 20 miles away to be able to do that. Much greater than most of the emissions that you're going to find with a LDAR Method 21 technology. So it makes it very easy to be able to do this, not only efficiently, but also safely. And then if you want to compare it to other technologies, the QOGI technology from FLIR and Providence, that it is a technology that has been vetted in multiple industry consortiums. And so various people have actually used this technology directly compared. And keep in mind, a lot of these are not even the FLIR or the Providence team. So I guess I should let you know, Providence Photonics is a partner of ours. We actually have a strategic partnership with them, and they're in essence our engineering team on development of the quantification of optical gas imaging, the quantification technologies, and all the algorithms that you start seeing here. So I don't know if Yoshing's in here. If you do have to ask a question about that formula I joked on, I can't answer it either, so don't worry. But what we've done is we've actually had some industry consortiums go out and actually evaluate our technology directly compared to other technologies. One of the most famous ones is one called CONCAWE, and that was out in Europe. And I don't know if there's another one gentleman in here that was part of that as far as an industry operator. I think he's in a different presentation right now, but they were actually doing it directed and not just comparing it to a TVA or sniffer. They're doing it directed. In other words, they're telling the sniffer where to go. And even in that case, optical gas imaging, as far as the quantification optical gas imaging solution, was over 5 times more accurate than a TVA or a sniffer in that application. Again, they're not finding the needle in the haystack. We're telling them where the needle is. Then they just have to actually go measure it. And then what do we do with this? What is the QL320 and what are we trying to do with this? It's just an accessory. It's a tablet that creates. Tablet looks like this that has a specialized, really powerful software built into it that allows you to quantify video files or live readings when you're using it with a FLIR GF320, GFX320, or GF620 hydrocarbon optical gas imaging camera. It's a development by our partner Providence Photonics, who makes the algorithm. They make they do all the special sauce inside there, and we work directly with them, in getting this to the market. You're going to be able to actually quantify this, not just a lot of quantifications. You're either going to get concentration or you're going to get mass. And the good thing about this, you're going to be able to quantify in mass. If you want to do volumetric, again, any of those, you can just get one number and change mathematics. But you can actually rerun this and run the entire quantification solution in concentration with a parts per million meter reading. So if concentration is of importance to you, this is a unique tool that allows you to have the entire gamut of quantification units to be able to use. And a unique thing about this is you can either do this in field and utilize the technology tethered, in other words, wired to the camera, or you can do it post-processing. And the unique thing about the FLIR cameras is we've put a feature in the FLIR cameras called Q mode. And what Q mode does is it allows the camera to store a specialized file that you can go out there and you can actually just record. Maybe you just wanted to record one or two of the big leaks that you saw. Maybe you wanted to record all 10 leaks you found that day. All you have to do is go and save that in the special file with the FLIR camera in Q mode, bring it back, and you can post-process it directly in the QL320 solution. So really unique in how it operates. And a little bit on the history of this. The first solution came out. Most people think this is a really, really new technology, but I know the Providence team, Yoshing and John, they've been working on this for many years. And in 2016, they had the very first really breakthrough technology for quantification with an optical gas imaging camera, technology called the QL100. And realistically, the FLIR QL320 we have today is just it's a foundational improvement on that QL100 that the team at Providence do a great job of making both grand improvements as well as many iterative changes and updates within the technology. When we first, we've been working with Providence since 2005, I would say. But when we came out and had in the first time we really, I got pulled into the picture, we really did the first step of strengthening that relationship went to Providence, and this is where we launched the Q mode feature and also had them develop the QL320, where it would be a little bit more streamlined with the FLIR camera and the FLIR camera user feedback. But even when we did that, we realized there were a number of things in talking to users, whether it be the user interface, how you use it, or some of the features inside of the camera, is where we really brought on the new FLIR QL320. Really an entirely new tablet that has a better processing speed and more durability. All the way to an entirely new user interface or a new user exchange that is very simplified and streamlined for the operator when they're out there in the field. And what we did is we actually mirrored a lot of that user interface to the FLIR camera. And so the drop-down menus that you would see in Q mode are going to be the same ones that you would see in the QL320, and they would look very, very similar in how they work. But one thing I'm sure a lot of you are here for is to talk a little bit about the new features, some of the advancements that we have. Some of these we may have put in, and some of these we will be looking to embed into the next generation of our quantification solution. As I mentioned, the first thing is the streamlined user experience. And what we did here, again, with a lot of the feedback, the QL320, the original, the blue branded one, when you hit save, you didn't always know what happens, right? You hit save and it's processing this, but you can't see exactly what is happening. So we added a results bar that allowed you to understand what's happening when you're operating this. We added a much improved user interface to allow more simplified masking features, and everything is right there in front of you. There's no drop-down menus where you have to go find the feature you're looking for. It's all laid out right in front of you, makes it a lot easier to use. And then we also added, expanded our unit options, in particular to add concentration readings with the parts per million meter reading built into there. And the last thing we did, we have a number of academia, a number of research people that like to use this. They like it tethered. They like the full option and the full feature set that you may have within the QL320. So we have an expert mode, but what we realized is that most of the operators, you wanted to streamline. I want to look and I just want it to give me a number. And because the challenge that you have is with our expert mode, a gas leak, you could have a gas leak and be looking at a gas leak for 5 hours in a lab with an OGI camera, and you're never going to get 2 sections of 10 seconds that look exactly the same. In a controlled environment, in a laboratory environment, a gas is turbulent, it's always moving a little bit different. So realistically, the number may change slightly. And so what we have is the normal mode where it just, you tell it that you're ready to measure, and it will actually hit this, hit the results bar, and it'll just give you an accurate number at the end. One thing that the Providence team is working on right now is something called edge masking. And what we realized in some, as we get user feedback, and you keep hearing me say this, but I want you to know, we welcome your feedback. For those of you that are optical gas imaging or QOGI users, or even the FLIR camera itself, feel free to come to us, our sales managers, and bring this back, because a lot of these features that we found are actually from you and saying, hey, we saw this and it didn't seem to work exactly the way that we thought. One new feedback is called an edge masking. So what you can see here on the video on the left is that at times you'll see a little bit of the colorized area on the edge of, as an example, a rail. And what's happening is, that rail may be moving, even though the camera's on a tripod, it might be moving slightly. Or the rail may be moving in the wind or something, or a pole might be slightly moving, even though you don't see it, might be slightly moving in the wind. So you can see on the video on the right, they have a buffer outside of any hard change in temperature. In other words, if you're going to have an extreme change from hot to a cold to a hot. So they put a little bit of a buffer outside of that so that they can use this and you don't have to worry to do things like, for example, some of our masking features where you actually can chop off the edges of the circle. You don't have to worry about doing that because the technology is going to actually advance itself, and it's gonna take care of that with that edge masking. So really exciting type of application. Another one here, you'll actually see the base of the tank, I believe, have a slight movement in that edge masking. Actually, this one didn't have that, but I'm sorry, over here you'll see the piping right here where the gas is kind of following that and wrapping around it. with an edge masking, you can easily see how we're going to go ahead and take that hard change where it goes from the sky background to the pipe, take that hard change and write only where that hard change moves from hot to cold or cold to hot and mask that out. One thing that I'm super excited about, and the Providence team has done a great job of tackling a challenge, is on stabilization. One of the complications, not complications, but one of the things that you need to do when you use the camera is, because we're moving, you're looking at a moving plume. And if you're moving the camera, looking at a moving plume, everything looks like a plume because it's all moving as well. So it begins to be a little bit more challenging to do that. I have a number of operators that just say, I can keep it pretty steady. I love using a monopod as an example, and not a tripod, because it helps in the stability, holding the camera up. But what the Providence team is really tackling right now, and they're on the precipice of getting this completed and integrated, is full stabilization of the ring. So we're looking at not stabilizing the image. There's different ways. As an example, a lot of the cell phone stuff, when you do this, it'll crop out. And so if I hold a high resolution camera and I move it left and right and top up and down, I can crop out 10% of the edge of the image and realize where I'm going. But then you start losing resolution on an infrared camera that doesn't have 20 megapixels of resolution like you might in a visual camera. What they're able to do is they're actually stabilizing the ring. This is an image taken from a handheld video standing on a boat, and you can imagine how challenging that would be. Those of you that stand there, and complain about maybe a little bit of a challenge standing on a catwalk between tanks. Imagine having to stand on the bow of a boat taking video with an optical gas imaging camera. A little bit challenging. And the Providence team has done a really good job of actually stabilizing the ring to keep that inside there to get accurate temperature readings. And we're really working hard and very close to a generation where we can get rid of the need for the tripod. That may not happen with all of the units of measurement, but we can get rid of the needs of the tripod in some different ways. If I look at that, as I take that one that you just looked at, you can see, let me go back here just real quick. You can actually see, this is moving around. You see all this multicolor here. It's having trouble finding that. But as the Providence team stabilize the ring, you can see they get rid of a lot of the colors right there on the stack that were challenging in doing that. It stabilizes the ring. The ring's not moving around, and it gives them the capability of having a really good job testing this without tripod measurement. Right now, it's currently in testing, but we're very excited about this as a short upcoming feature within quantification of OGI. Another thing I'll talk about, and Yoshing, feel free to correct me if there are any things, but the Providence team has been working for a considerable amount of time directly with the EPA and ERG in doing testing on internal floating roof tanks. And being able to have a calibration. One of the challenges with the QOGI solution, it's really easy whenever it is a point release. When you actually have a release coming from a single exit velocity point. But when you're looking at an internal roof tank, the sealing around there, it's a lot more challenging to be able to do that. And the engineers there at Providence have done a great job and have done some evaluation with Eastern Research Group on doing this. What this is their simulation. This is the roof of, as Johnny would call the nursery, but the roof of the roof of the building where their test lab is down here on the bottom, overlooking that, and allows them to get field data there at their office and to be able to evaluate the internal route, the IRFT solution. The calibration equation is going to be the next step is going to be to evaluate this through some field work. To give you some example of what this might look like, this is a place we're about 20 meters away in this video. I believe if this is 20 meters, they may be using a 14-degree field of view, a 12-degree field of view lens. They're doing this with propane releases, and this is just so that they can derive the calibration curves to be able to quantify that. And again, the next step is to move forward. Again, the EPA ERG are the ones that gave the Providence and the FLIR team permission to release some of these videos, but we're really excited about the next steps in doing some field work analysis. And if you're interested in partnering with Providence on that, feel free to let us know. Looking at the evaluation results, I wasn't a part of this, but one of the key errors is the aggregate error over all of the testing in full, with an aggregate error of 1%. Now, if you think about that, that is astronomical in any type of quantification tool. But to be able to get a challenging, a challenging application like floating roof tanks, and to be able to have an aggregate error of that at a 1% error is really, really good, with a standard deviation absolute of only 19%, under 20% standard deviation. So very consistent in its measure, and really, really impressed. But with that, they can also do the concentration. So it's not limited to your mass and volume measurements with the QOGI solution. So they do have that. The aggregate error here was, again, a negative 3%, a single digit aggregate error with the testing that they've done. And again, with the concentration, it's a little bit easier because you're only taking the intensity of the pixel. You're not taking the movement of the pixel over spatial distance and being able to quantify that. So they're really doing a good job. It's a simplified process of the QOGI solution. Again, really good results with what they've had. The conclusions, again, an absolute error around 25% with a 1% true emission rate as far as an aggregate error over the full testing. The next steps for this is going to be some field testing. It's really good. It's a little easier to do when you have this, but when we look at the setup that you have there, keep in mind, this wasn't just the Providence team building that for their opinion and what they had. The setup was with the full input from the EPA and ERG with evaluation. So this wasn't Providence just finding the right solution with the FLIR QL320. This was actually directly input from the EPA. The last thing I want to talk a little bit about, I may give you some time back, is some of the validation studies. One of them I've already briefly mentioned, and there's two new ones since we've had the most recent 4C conference. The CONCAWE study is something that the Providence and FLIR team talked about a lot. This is the one that we brought up. This was, again, a European, it's called the CONCAWE. So it's an environmental science for European refinery. And so there were consultants from the operators, both in the US side as well as on the European side, that provided input. And there were 61 test scenarios. Keep in mind, the testing that we did here directly compared to a TVA or sniffer, the testing that we did was with the QL100. This was with the first generation. There have been a number of not just user improvement features added to the QL solution, but also some advancements in the technology itself to streamline and to tighten up the accuracy of a QL320 in the QOGI solution. Leak rates were up to 1,000 grams per hour. Pretty much in a general distance. I think Terrence would probably agree. Inside of 10 meters is pretty common in the applications that they're trying to get. Most applications for OGI, and looking at a 3 gas, both individual as well as a mixture. This is a public study. It is available on the CONCAWE website. Is welcome to go read all 40 pages of it. But I'll try to summarize it in one slide, at least in our opinion. If you were to pull the summary of this, this is the method 21, again, a directed method 21, where it was told where to go to be able to go measure that. The average differentiation, the comparison of differences with the QOGI solution, again, generation 1 of our QOGI solution, a 6% average error compared to 31% of the baseline of regulatory drive in the U.S. for downstream in using this. So being able to do these direct comparisons from 6%, again, 5 times, a little over 5 times more accurate and better at finding and defining and quantifying leaks compared to right now the gold star, if you will, on many of the applications downstream. And so the technology has been advanced greatly on this. Many of you have seen this slide. What you probably haven't seen is the AMFC study. So in Alberta, they had a study with, this was unique in the sense that neither FLIR nor Providence were involved at all. This is a study of academia, and the goal of this study was twofold. One, evaluate other and if generational methane mitigation technologies. But if you're going to evaluate those, they actually needed to be able to quantify what they're trying to evaluate, because they wanted to evaluate not just qualification, but also quantification. And so in doing that, they also evaluated extensively the QL320 solution in this. FLIR and Providence weren't around. And if you recognize some of these names, some of these people are a little critical of optical gas imaging over the years in their academia work, rightfully so, and they stretch pressing the envelope. But this was, done by some people that are really out there trying to find the next generation. And we do have a link. It's hard to find on the PTAC or the AMFC website, but I can easily get you the link if you're interested. This was over 100 tests out in the field when they evaluated the QL320 as far as accuracy goes. The baseline outcome of this, the baseline result of this, was that in an individual, and this is one of the things with the QOGI solution, if I'm going to go look at one leak and say that I'm dead on accurate with one leak, that's going to be a little bit more challenging with the QOGI technology. But the baseline of this entire this study was, if you use QOGI in aggregate reading, and that aggregate doesn't have to be millions, but if you use it, in this case 100, if you use it in an aggregate reading, maybe that's per district, per basin, per site, whatever it is, the more readings that you have, the better the accuracy of the QOGI technology and the QL320 solution. So as we're looking at this, we had an 18% aggregate error with this, and again, this wasn't the experts using this, and we've had some statements in the past. Well, that was FLIR, or that was Providence out there doing that study or doing that. This was somebody, a third party, completely operating this, associated with our company. And if you look at a lot of the comparable results to kind of the gold star for mass or volumetric emissions in a back-of-rack high flow, they're usually around a 10%, much more challenging to use. You can't use, DTMs, you got to tape it up. It's a bit of a cumbersome technology, the years to use, really accurate for mass and volumetric. And we're looking at an 18% aggregate error versus a 10%. And so the other huge advantages of this is the wide range of emissions that we can detect as far as size. The back-of-rack high flow, as an example, has a limitation, a top-end limitation of 480 scuff. Whereas if you're looking at the QOGI technology, you can get all the way up to 3,000. So you're talking order of magnitude, 6 times more higher top-end reading for you to be able to quantify those. So it really adds a lot of opportunities. And again, I don't even talk about the UTMs and the DTMs because this was mostly upstream, but there are a lot of applications there where it'd be challenging for you to be able to get a high flow or even a TVA to be able to measure something like that. So what we decided to do after seeing that results is we went to the METEC facility there in Colorado State, and we said, well, we were testing a handful of FLIR optical gas imaging and methane mitigation technology site. But while we were there, we wanted to go ahead and see if, again, this was done by FLIR, but we wanted to see if we could get similar results to the Alberta Methane Field Challenge or the AMFC study. And so we took over, I believe, 80 data sets. And this was all done with the Q mode, right? So we didn't even take a QL320 with us. I don't even think we took it out in the field. So we walked out and did everything via Q mode. So we couldn't sit there and analyze stuff and change stuff with the QL320. So everything was taken Q mode and it was all post-processed. The range in leaks that we had were four to a shade under 100 liters per minute. And this was actual leaks, and the METEC staff is the one that controlled the leaks. They control the leak rates. We didn't know anything about it. They gave us a spreadsheet after the fact and said, this is what test number 1 was and what we looked at. So then we can actually go run the QL320 data independently through Q mode and process those. One really good thing about this study is that the environmental conditions were ideal for testing. What you would like the most in environmental conditions is wide range of testing. The first day we got there, it was misty rain, 32 degrees, and super cloudy out there, and it was not fun. But over 3 days of testing, it was from not a great day. The only thing we didn't have was a boatload of snow there in Colorado, which happens often. But over 3 days, we went from 32 misty and cloudy to 75 and perfect perfect OGI conditions with no clouds in the sky and a beautiful fall day there in Colorado. So we got a great overview and a great breadth of weather conditions to be able to test, and we got really lucky in a 3-day span there. So some of the samples that we would have, we did utilize, because this was before, and I know that the Providence team is looking at, taking in. The good thing about utilizing the METEC facility for us, at least, is we just got a boatload of data. Some of these sample sets are some of the things that Providence team is looking at in some of those mask edging, the mask edging feature that I showed you earlier. But these are just some of the examples of some of the leaks that we have where we've maybe masked out some areas that we wouldn't even need to use now with the next generation of QOGI. But the results of the data, very consistent with the AMFC. And in the overall results of this, of 87 data sample sets, we had an average error, top to bottom. The average error was around 25%. But our aggregate error, full-on aggregate error over 87 data sets. Again, the larger the sample size, the larger the aggregate sample size accurate that you're going to get with this technology, according to both us, or according to the Alberta Methane Field Challenge, Harrisburg University, and those guys, PTAC. And we realized in our study is the exact same results. Individually, you may have an error, an average error individually of around the 25%. But aggregate-wise, the more data sets you have, the better that solution is as far as being able to get you streamlined and really accurate data for quantification. And this is one of those support pages. We do have a handful of different support things on here. Everything from just the information on the product. We have some new training videoettes where they're all about 3 minutes or so, and it's one of our sales managers went out and just said, "Hey, here," and it's a video recording of him. I've also done we have our CustHelp quick start guides. This is it's on the actual desktop of the camera, of the tablet when you get it, but you can download that. A lot of quick links, and I can get those to you. One of the new things I did for those of you that may have been in the QOGI training is I actually recorded a training that I did within our global organization. So everybody that has a FLIR responsibility for oil and gas or optical gas imaging, as well as every partner that we have across the globe that might at some point in time sell or demonstrate this. I did a training, recorded that. It's about a 2.5-hour training, but it's a very intensive training for QOGI. And really informative. And be honest with you, it's almost a cut and paste example of what I did yesterday morning. For those of you that attended that, and maybe you'd have others within your organization that may be interested in learning a little bit more about the technology. And then we do have some white papers. Our goal in the white papers is to realistically keep it simple. And one of them is just the basics. It's about a 2 or 3 page white paper on just understanding the technology. The other one is a lot of times one of the easiest way to communicate is with the questions that you give us. And we took the top 10 questions that we get from operators and users in the field, put those out, worked with the Providence team to make sure we answer those, and just threw those in a white paper. All of those are on the FLIR.com website. And that is all I have today. Are there any questions? Or Yoshing, did you have anything that you'd want to add on the technology of the presentation? Nope, good to go. Any questions? And nobody fell asleep except you, but you work for an asking. Yes, sir.
Files that are downloaded.
Mm-hmm.
The technology improves, those files be able to line better and better as time progresses. Files that are taken by the camera are only as good as the camera. So the camera part has to be upgraded as well, along with the analytic formulas in the.
Mm-hmm. Mm-hmm. Yes. To answer the question, one, your data is going to be as good as your operator. So you're going to have the limitations in what you do if you don't put the right data. So one of the things with the QOGI solution or the QL320, you do have some input data that you need to put, right? You need to say how far away. If you're thinking each pixel has a certain spatial size, and I'm watching those pixels change from left to right, right to left, as it's moving across the screen. So there is some data, and we're trying to find the right ways to make user intensive. That's a little bit more challenging. But once you get that, as long as you have a steady camera, and as I talked about, we're working on even in making that better with the stabilization. But once right now, if you have a steady camera and you get the data, you get the video. One thing we did add to the camera itself, the Q mode, one big challenge that we had initially is the delta T. So you have to put in your ambient air temperature, and you can do that by waving this and taking the temperature of this in front of the camera. That's the ambient air temperature of where I am. You can have a thermoanemometer around to be able to do that. So there's different ways to do that. So you have to put the ambient air temperature. Usually, if you go on a well pad, as an example, take the ambient air temperature at 10 a.m. by the time you leave, it's not going to change by more than a couple of degrees. Unless you're in unique times of the day. Maybe when you get to the next site after, a small drive or an hour, maybe you'd want to recheck that. But what we did is we added the delta T, and let me show you the delta T compensation. And what I mean by that is this red area. This red area means that the temperature that you're telling the camera that the gas is. In other words, the gas, by Boyle's law, the gas takes form of whatever area it gets into very, very quickly. So the ambient air temperature where you are, more than likely where the gas is, it's taking that in a 2-degree span. Okay, so plus or minus 2 degrees, and it's dropping that in red and saying, we're not going to be able to quantify anywhere that you see red. If the whole image is red, if all of this were red, then you really couldn't quantify that. What we've done to answer your question, and this is what both FLIR and Providence are making iterative changes, continually trying to make the product better. We added a delta T compensation into Q mode. So now in the camera, you set it up, tell it the temperature, and it will put this red overlay on the camera. We don't have the colorized plume overlay on the camera, but we will. But that is all. That's just sexiness, right? That's just to make it look pretty. The actual red means something. That's for operation. And if you see red on the entire image, you would know that, all right, I've got an issue and I'm not going to be able to quantify that. So we're making those changes. I will say that we're continually, so once you get that data, and as long as you have a decent delta T, everything else can be done in the tablet. We are doing everything we can, working with users and feedback from them, working with the Providence team, and working with the FLIR team in my FLIR research and development engineering team to take as much of the technology, streamline it, push it together, and make it more and more and more user friendly. We have some end goals that we want to hit, and we feel as though we're pretty close to it. But some of that, some of those I talked about today, some of them I didn't. Yes, sir.
Emphasize history and also range.
Mm-hmm. So we are investigating that as one thing FLIR does is we make a full suite of test and measurement devices. We're looking at, I don't know if it'll happen, to maybe take that if you had a Bluetooth enabled thermal anemometer, you could have the wind speed and you can have the ambient air temperature, drops it in there. If you also had a laser distance meter on there, that would be great too. But I don't know if we're going to get there. It's under consideration. I'm not going to say that my engineering team feels as though it's of as much importance as I might feel in the next generation. But it is something that yes, we are looking into the right solution there. That, you know, we don't have 5G in the camera or LTE, so we can't say, all right, this is the weather conditions today on this site in Austin, Texas. You know, it'd be nice to be able to pull that stuff down and have it automatically at it. I don't think you would know the cost of the camera if we put an LTE in there and had it talk to a cell tower. You know, probably wouldn't like that. But we're doing what we can to try to, I mean, I promise you we're doing everything we can to try to streamline the operation. Yeah, Terrence. There's something I didn't talk about today that we feel we're close to having finished in the very near future, and that would be included in that statement. Yeah. Anything else? I think I'm 3 minutes early, so I appreciate your time. As I mentioned at the beginning of this, thank you. There's a lot of presentations and you allotting some time to us. Feel free to my information's not up there. Feel free to find me. I'll be at the FLIR booth or running around. I'll reach any FLIR person, and we'll be more than glad to help you out with your infrared, optical gas imaging, or even QOGI needs. Thank you.